Now welcome my students. We are going to discuss the JEE Main 2020 September 3 Shift 2 Physics paper. Come to the very first question. Two resistors are connected in series across 6-volt battery. The potential difference measured by a voltmeter 10 kilo ohm across 400 ohm resistor is close to. Now the figure you can draw like this. There are 400 ohm, 400 ohm and 800 ohm connected in across 6-volt battery. If there are no further informations are there, at once we can say 6-volt is divided in the ratio 1:2. Therefore, what is the voltage across this one is equal to 2 volt and across this one is equal to 4 volt. 4 volt. That is the answer. But it is given that potential difference measured by a voltmeter. Here we are going to connect a voltmeter across this. And its resistance is 10,000 ohm. Then what is the effective resistance of this part? The effective resistance of this part is given by, what is the effective resistance? Effective resistance R effective of this part, R dash if I call. R dash is equal to R effective is given by R1 R2 10,000 into 400 by 10,400. Now this value is slightly less than 10,000. R1 R2 by R1 R2 by R1 plus R2. That is the value now you got, and therefore its value is slightly less than 400. This is slightly less than 400. So this is the fact. Now 6 volt is going to be divided among two resistors. And now instead of that, now I am going to the right. Here there is a resistor, and what is that resistor value? 40,000 by 104. This one. And this is 800 ohm. And here there is 12 volt. Question is, what is the drop across this one? Formula, applied voltage. So our answer, V dash is given by, V dash is that, V dash is given by applied voltage into fractional resistance of that resistor. That's okay. Fractional resistance of that resistance. That's equal to 40,000 by 104 by 40,000 by 104 plus 800. And this value on simplification, the value is found to be 1.95 volt. This value on simplification, 1.95 volt. If 1.8 was not there, then without a calculation we can give the answer. Without giving, because I told you if this instrument was not there, the value is equal to volt. Therefore, our answer is near around 2 volt, less than 2 volt. But there are close values, 1.8 and 1.95. Therefore, elimination technique cannot be applied. You have to calculate this one and get the answer. So, value is equal to 1.9. Now, next question. And definitely a simple one. Hydrogen ion and singly ionized helium ion are accelerated from rest through the same potential energy. The ratio of the final speed of hydrogen and helium ion. Now, hydrogen ion and singly ionized helium ion mean the charge on both of them are the same. And when same charge accelerated same potential, the electrical work done or gain in kinetic energy are the same. Therefore, because the electrical work done is given by E into V. Here V is the same, charge on both of them are the same. One is fully ionized hydrogen and other one singly ionized helium. Therefore, EV is same or energy is same. And here the ratio of the final speed, since energy is same, kinetic energy is same. Therefore, kinetic energy of Ke of hydrogen half mass of hydrogen into velocity of hydrogen square equal to that of helium, half mass of helium into velocity of helium square. This will cancel out. And we have to get the speed of hydrogen to helium. So VH by VHE is equal to VH by VHE is equal to MHE by MH. Note. Mass of helium 4 by 1 is equal to. So the ratio is equal to 2:1 and option is 4. Simple question. The following is not to be observed when a multimeter operating on resistance measuring board, probe connected across a component are just reversed. We have a device like this. Earlier connected multimeter is connected like this. Then reverse. The 1 and this is 2 again. In second case, either 2 ohm is 1 like microseconds. Now energy supplied by this to this diode. If you come to the question, it is not observed. Not observed. You can go through each option. I am coming to the answer option. Now look at the fourth option. It says that a multimeter shows no deflection in both cases if before and after reversing the probe, if the chosen component is a capacitor. If it were a capacitor, I am drawing, this is a capacitor and connected to a battery. That's okay. Till whether we change the terminal or not, the capacitor will be get charged and attain max up to that. So that means up to it get attain maximum charge. There will be current in the circuit, and therefore we can say that there will be deflection. But in the problem it says the multimeter shows no deflection. That is wrong. Multimeter will show no deflection only when steady state is attained. Up to that there will be deflection. Therefore the fourth option is wrong. In all other options they are correct. And for not observed when multimeter, that is the option is equal to 4. Option is 4. Simple question. Next. A ionized magnetic field exists in a direction perpendicular to the plane of a square loop made of metal wire. The wire has got a diameter 4 mm and a total length of 30 cm. The magnetic field changes time at a steady rate of dB by dt 0.032. The induced current in the loop is close to resistivity of the material is given and induced current. Now come to our question. Here the entire length of the loop is given. In the problem it is given that 30 cm and it is bent to form a square loop. It's bent to form a square loop like this. Total length is 30. Then what is side length? 30 by 4 into 10 raised to minus 2 meter. That is side length. Side length. Side L is given by that. At once, what is the area of the loop? Area of the loop is equal to 30 by 4 into 10 raised to minus 2 whole square. Because it's a square loop, meter square. Now you got area of the loop. And we just said that it is kept in a magnetic field. And what is the flux through that? Flux through that is given by B into E. Only one turn is there. Then what is the induced EMF? Induced EMF is given by d phi by dt. Minus I am forgetting. And which is the variable there? It is the B is the variable there. A remains the same. Therefore, A into dB by dt. Because it is the magnetic induction changing with the time. The induced EMF is given by A into dB by dt. So that induced EMF A into dB by dt. Next, we want to get what the current. Current I is given by, E can be calculated. E, here you can calculate like this. A is given by this much. Therefore, induced EMF E is given by A 30 by 4 into 10 raised to minus 2 whole square into dB by dt is given. dB by dt is equal to 0.032. That much volt. Compute and get that. This is the induced EMF E. Question is induced current. To get the current, we have to calculate what is the R of resistance of that wire or loop. Resistance of that conducting wire, R is equal to basic formula rho L by A naught. Basic formula. That on calculating. Rho given to you 1.23 into 10 raised to minus 8 into L. L is the length of the loop. Length of the loop is 30. 30 into 10 raised to minus 2 by A, area of the loop. That is given here. Area of the loop is area of the wire. Area of the wire is given by small and where area of the wire. Area of the wire is given by pi into radius square. Radius of the wire is given. Diameter of the wire is given 4 millimeter. Therefore, radius of the wire is equal to 2 millimeter. Therefore, area cross section of the wire is given by 2 into 10 raised to minus 3 whole square. So this is our R. So much O. Then question is, what is the current? Induced current equal to EMF by resistance. Now substitute, compute both and substitute, you get the answer. But here, the EMF on calculation, if you apply this data, EMF on calculation, the value is equal to 0.00018 volt. And the current on calculation, R on calculation, 2.93, this on calculation, 2.93 ohm. And the current on calculation, if you do, the current on calculation is bound by 61 into 10 raised to minus 4 ampere. That answer is not there. Therefore, the question number 4 has no answer. Some data that they conveyed are missing. That is why this happened. The answer is not there within that. Come to the next question. Two light waves having same wavelength lambda vacuum are phase initially. The first wave travel path L1 through a medium of refractive index N1, while the second wave travel a path L2 through the medium of refractive index N2. After this phase difference between them. Now, suppose these are the two slabs. This is L1, refractive index N1. This is L2. This is L2, refractive index N2. Two waves enter into in phase. When they come out, what is the phase difference? It is asked. What we are going to calculate, what is the optical path of first medium and second medium? Optical path, OP, optical path is given by N1, L1. For second one, optical path is given by N2, L2. Optical path now. Then what is the path difference between these waves on coming out from their respective media? So path difference given by optical path of first one N1, L1 minus N2, L2. The path difference. Now the path difference, we have to convert that into time difference. Now what is the time difference between them? Time difference. Path is then, time is given by c, velocity. And therefore, time difference. Or we can say path difference is obtained. Then the question is phase difference. And path difference is given But how you calculate the phase difference? There is no need of going to time difference. Path difference you got. And phase difference is given by formula 2 pi by lambda into path difference. So 2 pi by lambda into path difference n1 L1 minus n2 L2. 2 pi by lambda into n1 L1 minus n2 L2, option is 2 there. Again, moderate question. Question number 6. A methanosphere of cooled from 50 degrees centigrade to 40 degrees centigrade in 300 seconds. If the atmospheric temperature around is 20 centimeter, then the sphere temperature after next 5 minutes will be close to. Earlier 300 seconds mean 5 minutes. Again that same interval is given next 5 minutes. How much is the fall in temperature in 10 degree? Therefore, second case it is not a 10 but less than 10. What was the 50 to 40? Next is 42. 42 at temperature definitely not 30 but greater than 30. Now how many options are there? There are 3 options. 31, 35 and 33. And therefore definitely we have to calculate. Otherwise we can do the elimination technique. But here there are 3 options which is greater than 30. Now what you are going to apply? Newton's law of cooling. Newton's law of cooling. Rate of cooling. Rate of cooling proportional to our concept mean difference of temperature between the body and surrounding. In first case, apply Newton's law of cooling. Rate of heating or rate of cooling 50 to 40. 50 minus 40 by time 300 seconds. 300 is the rate of cooling proportional to mean difference of temperature between the body and surrounding. 50 plus 40 by 2. 50 plus 40 by 2 minus room temperature 20. That is here we can say that is equal to 20 by 10 by 300 proportional to here 45 minus 20, that is 25. Equation number 2. Next, again we are repeating. Here the initial temperature is 40 and it is cooled to unknown temperature theta dash or theta. Then 40 minus theta by the same time 5 minutes. 5 minutes means 300 seconds. Proportional to mean difference of temperature. What is mean difference temperature? Initially is 40. Final is theta by 2 minus room temperature. This is equation number 2. Now divide and equation number 2 by equation number 1. Solve and find the value theta. Now we have got divide equation number 1 by 2. Divide and solve for theta. Divide and solve for theta. And on doing, you get the value of theta as a mathematical part I am not doing, and you got the answer is 33 degrees centigrade. The option is 4. Calculation difficulty is there. Physical concept theory is very direct and simple. Mass density of a planet of radius r varies with the distance r from its center as rho r is equal to. Then gravitational field is minimum. Now the question is what the gravitational field is minimum where it is us. Now suppose this is the sphere. If we take a shell at a distance r from here with the thickness dr, if we consider a shell with the thickness dr there, what is the mass of this shell? this shell. It is at a distance r. No, r is a variable there. Or x, say x. Then what is the mass of that shell we have to calculate, of that spherical shell? dm, we can say. dm is gone by dm of that 4 pi x squared area into thickness dx. 4 pi x squared dx is the volume of the shell into density. Density is given by rho 0 into 1 minus r squared by r squared. This is dm. Then we know as we go out, what is the m value there? Variable is r, therefore instead of x is this r, it is better. Our dr. Then what is m? For a distance r. For a distance r, m is given by integral dm. Integral dm, if you do that on doing, get this is equal to 4 pi rho 0, 4 pi rho 0 bracket r squared minus, here this become r raised to 4 by r squared integral. This on integration 4 pi rho 0 into that on integration is equal to r cube by 3 minus. Next one, that on doing r raised to 5 by 5 r squared. This is our m. Now once you got the value of m, where m is the mass of that sphere of that part whose radius is r, up to that radius r, small r, where m is not the mass of the entire one, but it is that m, an inner sphere having a radius r. When r radius increases, the mass of that inner sphere that go on increasing. Then what is the intensity of this, that inner sphere whose radius is small r, which is less than capital R? The radius r is less than small r. Then what is the gravitational intensity at the surface of that inner sphere of radius r? The gravitational intensity is given by, the gravitational intensity is given by, I is given by, or basic formula, Em by r square. Here we can write that is equal to G 4 pi rho, and here capital R is equal to small r by small r squared into r cube by 3 minus r raised to 5 by 5 r squared. Take that inside. This become 4 pi rho r by 3 minus r cube by 5 r squared. This is I. Now in the problem, what is us? The problem, it is us. The field is maximum. The field intensity is maximum. For which what we are now, field intensity is a function of smaller. Differentiate. For differentiating, or we are finding di by dr. Find di by dr and apply the condition for maximum or minimum. Condition for maximum. that the first derivative must be 0 and the variable is r. So we are finding di by dr we are finding and put that is equal to 0. If we find the condition for maxima, di by dr, if you do, that is equal to 4 pi rho 0 bracket. Di by dr, if you calculate what is the value of di by dr that you obtain, 1/3 dr by r 1, that is equal to 1/3 minus the other one on calculation r cube is equal to r squared 3 r squared by 5. Now find di by dr. Di by dr is given by this term, and for condition for maxima this must be equal to 0. This must be 0 mean this bracketed term is equal to or equal. Therefore, by applying the condition for maxima, 1/3 is equal to 3r squared by 5r squared. And we have to find the value of r. Therefore, r is equal to root of 5/9 r. R is equal to root of 5/9 r. Now going through our option. Root of 5/9 r, that is equal to. The answer is 2. Now if you grade is a difficult question, definitely it's a difficult question. Yes, next question. A block of mass 1.9 rests at the body of table height 1 meter. A bullet of mass 0.1 kilogram collide with the block and stick to it. The velocity of the bullet is 20 meters per second in the horizontal direction just before the collision. Then the kinetic energy just before it, the combined system strike the floor. Now, if you do, here there is our block, mass 1.9, and here there is our bullet, 0.1 kilogram. 0.1 kilogram. And bullet of mass collide with the block. The velocity of the bullet is 20 meters per second. Just on collision, and it is at how much height? The collision, the velocity rest on the edge of a table of height 1 meter. This is 1 meter. Now on hitting the ground, what is the energy? That is what. Assume there is no rotational or loss of energy after the collision. Now we have to calculate what is the velocity of the combined mass, for which we write down moment of conservation. 0.1 into 20 is equal to, this one was a test, and after collision its velocity become v dash. After collision, before collision this is, and what is the total mass after collision, which is embedded inside. Therefore total mass is 1.9 plus 0.1 that is equal to 2 v dash. Therefore v dash is equal to 2 by 2. This is 2 by 2 is equal to 1 meter per second. The velocity of that body you got. And therefore, on reaching the ground, what is the total kinetic energy? It's initial kinetic energy plus the gravitational potential energy become kinetic energy. Therefore, total kinetic energy on reaching the ground is equal to, is initial kinetic energy half total mass m plus m, that's equal to 2 into v dash square plus mgh, that's equal to, what is the m2 into g into 1, that is equal to half into 2 into 1 squared plus 2 into 10 into 1. This one calculation is 21. Therefore the answer is 4. And again is a moderate question. The radius r of a nucleus of mass number can be estimated by the formula. It follows that this mass density of the nucleus is of the order of, and no need of doing the questions. So non factor that if you look into the option, its value is equal to 10 raised to 17 kilogram per meter. mass by volume. So density rho is given by mass. If A is the mass number of the nucleons, A into mass of a nucleon, whether proton or neutron, that is going to be by pi radius square. Radius is given 1.3 into 10 raised to minus 15 into a raised to 1 by 3, a raised to 1 by 3 whole cube. This one simplification, a cube, a raised to 1 by 3 cube a, that will cancel out. So what remains is m by 4 by 3 pi. 4 by 3 pi r cube, 1.3 into 10 raised to minus 15 whole cube. Here m is given 1.67 into 10 raised to minus 27 by 4 by 3 into 3.14 into 1.3 into 10 raised to minus 15. Okay. This is a standard value. But there is no need of doing this, because in the option if you look, then here around the value is equal to 10 raised to 17 nuclear mass density. Without doing, you can get the answer. It is option 1. So it's a knowledge type question we can see. Two sources of light emit X-rays. Wavelength 1 nano visible light of 500 nano respectively. Both the sources emit light of the same power, 200 watt. The ratio of the number density of the photon X-ray to number density. It is given that power is the same. Power is given by power. If n is the number of photons per second at c by lambda, and power is the same, therefore you can write n1 at c by lambda 1 is equal to n2 at c by lambda 2. Power is the same, so cancel out. And the question is the number density, so n1 by n2, so lambda 1 by lambda 2. Lambda 1, first one, X-ray, lambda 1 wavelength 1 nano by 500. So it's equal to 1 by 500, and the option is equal to 4. That is question number. Next question. Now we know it is in the problem, a particle is moving unidirectionally on a horizontal plane under the action of a constant power supply energy. The distance s and time t graph describe the motion of the particle is not on scale. Structure is required. Now in the problem we know constant power is said, power supplied constant. Power is given by force into velocity. Force is mass into acceleration into velocity. From this, acceleration A is equal to P by M acceleration is equal to P by M into, and A is equal to dV by dt. It's equal to P by M. Rearranging, V dV is equal to P by M into dt. Integrating, V squared by 2 is equal to E by M into T. From this, V is equal to 2P by M T raised to half. This is root. V is equal to root of 2P by M into T raised to half. But V is equal to dx by dt, because we want to get the relation between x and t. Therefore, V is equal to dx by dt equal to root 2P by M T raised to half. From this, dx is equal to root 2P by M into T raised to half dt. Integrating both sides, x is equal to root of 2P by M into integral T raised to half. That is equal to T raised to 3 by 2 by 3 by 2. Now our dependence, x proportional to T raised to 3 by 2. Definitely a sharp path with increasing with the value of t. Therefore, option is equal to 4. And again, moderate question. Now 12. A semiconductor diode can detect a photon with a maximum wavelength of 400 nanometer. Then its band gap energy, Planck's constant is given. Now, lambda is given. Question is, lambda is given. What is the corresponding energy? That is all. When lambda is given, corresponding energy given in electron volt is given by 12.4 by lambda in nano. If it is nano into lambda by 100. Atharam electron volt. So the band gap energy is given by 12.4 by lambda 400 by 100. That is equal to 12.4 by 4 is equal to 3.1 electron volt. So answer is there, answer is 3. Simple question. A perfectly diamagnetic sphere has a small spherical cavity at its center, which is filled with a paramagnetic substance. Then the whole system is placed in a uniform magnetic field. The magnetic field inside the what is the magnetic field inside? This is dia, and this is para, and what is the magnetic induction there? When it is kept in an external magnetic field. When external magnetic field, when a diamagnetic substance is kept, the magnetic flux lines will be repelled out, and there will be no magnetic flux lines inside. Therefore, that is zero. Very, very simple. Therefore, the answer is 4. Our next question. A uniform rod of length L is pivoted at one end on a vertical shaft of negligible radius. When the shaft rotates at angular speed omega, make an angle theta with the figure. Find the value of theta. Pinulla data not needed. Center of mass to the torque provided by the horizontal and vertical forces about center. The value of theta is then such that. Now in this system, here there is a shaft, negligible mass. This is the shaft which is, and a rod is attached with it. When it is attached, not rotating, you can see that the rod will remain like this along with the shaft. But when it is rotated, it will rise. And at particular speed omega, it will remain like this. Why? Because there are two torque due to a vertical force, that is the gravity force. A torque is there. And we have to calculate what is that torque due to the vertical force. And the vertical force is mg downward. And this distance is L by 2. And therefore, this distance is L by 2 sin theta. Sin theta. Then what is the vertical force? Torque. Vertical force is mg. What is the torque due to the vertical force? R cross F. That is inward. Our toe vertical we can write like this. mg into L by 2 sin theta. Toe vertical. And it is inward. It is inward, and therefore I am giving the symbol like this. It is inward. Inward. Now, there is a torque due to a horizontal force. And who is that horizontal force? Fh. Fh is it's a rotating frame. The centrifugal force is there in the upward direction or horizontal direction. So that is the one which provides the horizontal force, the centrifugal force. And now to calculate that, I am drawing this figure again. This part. This is mass m, length L. Therefore, rho or this one is called m by n, mass per unit length. Now consider a small segment or this one at a with the thickness dx at a distance x. Now this angle is theta. Now this mass is rotating like this, and the radius of that circular path is x sine theta. Then what is the centrifugal force acting on that? D F horizontal. dF horizontal. Basic formula mr omega squared. What is m? M by L dx. What is r? Radius of that? X sine theta into omega squared. And what is the torque due to that small force? D tau horizontal. D tau due to horizontal force. No. D tau due to horizontal. dh. Horizontal. And the direction not torque not horizontal. Torque due to this force is equal to force in the perpendicular distance. That is equal to dF as such into perpendicular. What is the perpendicular? This is the perpendicular distance. This is the direction of the force, and this is the perpendicular. That is equal to x cos theta into x cos theta. That is equal to m by L dx into x sine theta into omega square into x cos theta. This is the, and what is the direction? Direction is, this is R, this is F, and therefore the force will be like this, inward, outward. That torque is outward, and therefore what is the total torque? So torque horizontal, so integral d tau h is equal to integral m by L sin theta cos theta omega square in x squared dx. All the terms included. Yes, m by L sin theta cos theta omega square x squared dx. That on doing, again that is equal to m by L sin theta cos theta omega square x squared dx, x cube by 3 between the limits 0 to L. Therefore that on integration is equal to L cube by 3. That is equal to m L squared omega squared sin theta cos theta by 3. And the direction, here it is inward and this one is outward. It is outward. For equilibrium, these two must be equal. These two must be equal. And therefore you can write d torque vertical is equal to torque horizontal. Therefore you can write mg L by 2 sin theta equal to this one, m L squared by 3 omega square cos theta sin theta. M will cancel out, 1 L will cancel out, sin theta will cancel out, and you get what we required is cos theta. Cos theta is equal to 3g by 2L omega square. 3g by 2L omega square, and option is difficult question. Definitely difficult question, this one. Next one. To rise the temperature of a certain mass of a gas 100 degrees centigrade, 50 degrees centigrade at constant pressure is 160 calorie of heat is required. When the same gas is cooled by 10 degree at a constant volume, 240 calories of heat is required. How many degrees of freedom is there? And now first data, at a constant pressure, heat required, how much? 160. 160 is equal to given mass. I am not going to write down the mass. That can be written out as Cp delta theta. What is delta theta? M into Cp delta theta, or N into Cp delta theta. Cp, what is the rise in temperature? Certain mass 50 degree. When the same mass gas is cooled by 20 at a constant volume, 240. 240 is equal to N into Cv into 10 degree or 100 degree. Dividing 160 by 240 is equal to Cp by Cv into 50 by 100. So Cp by Cv equal to 4 by 3. Now question is degree of freedom. Degree of freedom is given by, F is equal to gamma, F by 2 by F. F plus 2 by F is degree of freedom, that is equal to 4 by 3. So 3F plus 6, 4 by 3. 3F plus 3 is equal to 4F. Therefore, F is equal to 6. So degree of freedom is equal to 6. Rather moderate question. A block of mass M attached to a massless spring is performing oscillation motion of amplitude A on a frictionless horizontal plane. A half mass of the block is break off when it passes through its equilibrium point. The amplitude of oscillation of the remaining system becomes Fa, then the value of F. Now earlier it was oscillating. So suppose this is the block, the mean position, and this is the block, oscillate. Spring oscillate, vertical or horizontal. Amplitude is equal to frictionless plane when it crosses the mean position. Earlier, when it was a single block, when it crosses the mean position, its momentum is mv. mv. At the mean position, you know that the oscillating body is not subjected to any force. No force is acting while it crosses the mean position. And what happens there? During another situation, when it crosses the same position, that is no force situation, how the mass left off. So mass become m by 2. But momentum is conserved because there is no force. Momentum conservation. By momentum conservation, when it crosses the mean position, by applying momentum conservation, we can write that is equal to m by 2 b dash. Momentum is conserved. Therefore, when it is broken, before breaking, its velocity was v. After breaking, its velocity becomes v dash. So that v dash become 2. Velocity become twice 2v. Now, what is the velocity? Velocity for an oscillating body, when it crosses the mean position, maximum is going by a omega. Therefore, now we can say 2 into a omega is equal to a dash omega dash. Because V max is equal to a omega. V max a omega. This is our basic formula. Question is a dash. A dash will give Fa. So that is equal to F A into omega dash is equal to 2 into A cancel out. Therefore, F is equal to 2 omega by omega dash. Now, what is the formula for omega? For an oscillating system, what is omega? Omega is given by root of k by m. So now omega is root of k by m. This is the basic formula. Therefore, omega by omega dash is equal to root of m dash by m. M dash by m. M dash m by 2 is equal to root of m by 2 by m is equal to, this will cancel out 1 by root. It's equal to 1 by root 2, and therefore the option is equal to. Next question. Anywhere it is wrong. Omega is equal to k by m. K is the same. Therefore, omega by omega dash. Omega by omega dash is equal to m dash by m. M dash is m by 2 by m. That's equal to 1 by root 2. It's okay. Now, next question. Video now. Yes. Now come to our next question. An electric field of plane electromagnetic wave propagating along x direction. Vacuum. Given. The magnetic field will be at the moment t is equal to 0. What is the magnetic field at that moment? T is equal to 0. T is equal to 0 means what remains is equal to cos minus kx. Omega t is equal to 0 and t is equal to 0. Next. We know for a magnetic field, electromagnetic wave, C is equal to E by B. Therefore, B equal to E by magnitude. C is given by E into 1 by root of mu 0 epsilon 0. So, B0 is given by E0 into root of mu 0 epsilon 0. Next. What is the direction in which the wave is propagating? The wave is propagating along x direction, wave. And electric field above wave is propagating. C unit vector is along I. Unit vector of velocity is I. Positive x direction. Wave is propagating. Wave is velocity direction. Velocity direction is plus I. And electric field is direction of E. Direction of E is Y direction, J. Positive Y direction. Now you know E cross B is equal to direction C. Here C direction is, velocity direction is I. Electric field is J. J cross a tube is equal to Y. J cross a tube is equal to Y. And therefore, what that means be? J cross K, IJK you know that, and I must get I. I is equal to, what is the value of J? I, J, K. The cross product if I say J cross I, J cross K. I cross J, K. J cross K, I. J cross K, I. And therefore, the magnetic field is along, the direction of magnetic field is along Z direction. And what is Z direction? Unit vector along that direction K. And therefore, here it is equal to K. Now, coupling these two, the option is, the option is 2. Now, next question. Amount of solar energy received on Earth, surface per unit area per time is solar constant dimension. So solar constant energy per second per unit area per second per area. Energy m L squared t raised to minus 2 by second time t, area L square, and you can get that this will cancel out. Take that into numerator, m L raised to 0 t raised to minus 2. M L raised to 0 t raised to minus 2. Option is 1. Next question. Concentric metallic hollow spheres of radii R and 4R hold charges Q1 and Q2 respectively. Given that the surface charge density of concentric spheres are equal, sigma same, then VR minus 4VR. Now this is R and this is 4R. Sigma same. Therefore Q1 is the charge on this one. 4 pi R squared sigma. Here Q2 is equal to 4 pi 4R whole squared sigma is equal to 16 Q1. Q1 is, and this is 16 Q1. This is the charge on these two. Now given that the surface charge density, then one is inside. But now the figure can be drawn like this. This is 4R and this is R. Now we have to find out the VR and V4R. Here the VR is given by its own potential. Potential on the surface of a sphere that is equal to K, but the charge on the inner one Q1. So Q1 by its radius R plus potential due to the outer one, that is equal to K Q2, that is equal to 16 Q1 by its potential 4R. And this on calculation, Q by Q1 by R, 5, this will cancel out, 5 KQ1 by R. This is VR. Now what is V4R? V4R is the potential due to the inner one on the outer one plus its own. That is equal to K Q1 by 4R plus K 16 Q1 by its radius 4R. That on calculation, 17 KQ1 by 4R. 17 KQ1 by 4R. Now the question is the difference. So VR minus V4R equal to 5KQ1 by R minus 17KQ1 by 4R. This on doing. Now subtract and get the answer. That is equal to K Q1 by R. If I take 5 minus 17 by 4, 3 by 4, K Q1 by R, where K is gone by 1 by 4 pi epsilon 0, and therefore the option is 1. Next question. Next question is question number 20. So if the subtraction is correct, let me see. So I'm doing 17 kq by 4r. Yes. Next question. Next question is, a calorimeter of water equivalent 20 gram contain 180 gram of water at 25 degrees centigrade. M grams of steam at 100 degrees centigrade is mixed in it till the temperature of the mixture is 31. Then the value of M close to lighting heat of water is given, specific heat of water is given. Now, calorimeter water equivalent 20 and 180 gram of water together. So what is the total mass of the calorimeter and content is 180 plus 20 by 200. Calorimeter and content 200 gram. It is now at 25 degrees centigrade. It is mixed with m gram of steam at 100 degree, so that the temperature on the mixture becomes 31. Therefore, what is the heat gained? Gained by calorimeter and content. MC delta theta 200 into 1 into. So C deposit of water is 1 into. What is the rise in temperature? 25 becomes 31. Therefore, 31 minus 25. Equal to heat lost. Heat lost by whom? The m mass of steam that is added. M gram of steam. So m mass of steam first condense, and then what is the heat release is equal to m into 540. Plus, it cooled from 100 degree to 31. So m into 1 into 100 minus 31. Therefore, 200 into, that is equal to, here is equal to 6, is equal to 540 m plus, that is 69. 9 m. Altogether is equal to 609 m. Therefore, m is equal to 200 plus 200 into 6 by 609. And the value is found to be nearly is equal to 2. Nearly 2, and therefore option is 1. Next question. 21. If minimum possible work is done by a refrigerator in converting 100 grams of water at 0 degree centigrade to ice, how much heat in calorie is released to the surrounding at a temperature 27? Now, in the case of a nearest integer, in the case of a refrigerator, you know, it's a reversible engine, therefore Q1 by T1 is equal to Q2 by T2. Q1 is the heat rejected at a high temperature, Q1 is the heat absorbed at low temperature. Now, minimum possible work done. Of the 100 grams of release, the data is the minimum possible work is done by a refrigerator in converting 100 grams of water at 100 degrees centigrade. What is 100 grams of water at 0 degrees centigrade into ice? 100 grams of water at 0 degrees centigrade to ice. But the heat absorbed from water, heat absorbed from water is 100 grams at 0 degree into L, 80, equal to 80,000. That is the heat absorbed. Q2. Heat absorbed is equal to Q2. From the, now T1, T2, temperature inside, that is equal to 273 Kelvin. And what is the outside temperature? T1, 27 degrees centigrade, that is equal to 300 Kelvin. from which you can calculate Q1. So Q1 is equal to Q2 into T1 by T2 is equal to 80,000 into 8,000. I'm sorry. Here I am wrong. It is 8,000. 8,000 into T1 300 by 2,000. Now you got Q1. Then work done is given by Q1 minus Q2. That's equal to 8,000 into 300 by 273 minus 8,000. And this value on rough calculation is equal to 879. This value on calculation, this value on calculation is equal to 879. That is the heat absorbed. And the work done is given by Q1 minus Q2 difference, get the answer. Next, this is the heat rejected and heat absorbed. And the work done is given by, next, massless equatorial triangle EPG. Side A has 3 particles of mass m situated at the vertices. If the moment of inertia of the system about the line Ex, about this axis, n by 20 ma square, where n is the integer, then what is the value of n? The moment of inertia of this particle is 0 because axis passing through that. The moment of inertia of the particle, the axis, its contribution is 0. This is at a distance a by 2. This distance a by 2. Therefore, its moment of inertia is equal to m a by 2 whole square plus moment of inertia of this one is equal to plus m a square is equal to 5 by 4, the m a squared by 4 plus m a square is equal to 5 by 4 m a square. Answer is n by 20. About n by 20. Now, this can be written as 25 by 20 multiply m a square. So, what is the value of n? 25. The value of n is equal to 25. 25. So, that is the option. Simple question. Next question, 23. An object is kept at a distance of 30 cm from a concave mirror. The image is formed at a distance 10 cm from the mirror. The object is moved with a speed of 9. Then the speed in centimeter per second with the image move. Now, it is a concave mirror. In the case of a concave mirror, you know, law of distances say that 1 by v. In the case of a concave mirror, 1 by v plus 1 by u is equal to 1 by f. If you differentiate this one, minus 1 by v squared dv by dt with respect to time, minus 1 by u squared du by dt equal to 0 because f is a constant. Now here we are given that in the problem you are given that when an object is kept at a distance of 30 cm from the mirror, so u is equal to minus 30 Q1, concave mirror. Image is formed at a distance 10 cm from the mirror. V is equal to minus 10 given. And if the object is moved with a speed, the du by dt is given 9. Now dv by dt is asked. From this you know that dV by dt is equal to, take the other side, V by U whole square into du by dt. V by U, 9 by, sorry, this one. V by U, 10 by 30 whole square into 9. That is equal to 9 by 9, that is equal to 1. So dV by dt is equal to 1 unit. So the answer is 1.00. Next question. A galvanometer has got 500 turns and each of turn has got an average area. Its torque is 1.5, required to keep coil parallel to magnetic field, mean area vector perpendicular. When the current is equal to so much flowing through it, then the strength of the field. We know the torque required, maximum torque, basic formula BIAN sin theta. So max, so sin theta 1 is equal to BIAN, tau max. Because theta is equal to 90 degree, it is given. And here the question is the strength of the field. So B is equal to tau max by IAN. Tau max given, tau max is equal to 1.5 Newton meter. I, the current through, I is equal to 0.5 ampere given. Area of the coil is equal to 3 into 10 raised to minus 4 meter square. Number of turns, N is equal to 500. It's equal to 1.5 by 0.5 into 3 into 10 raised to minus 4 into 500. Now solve and get the answer. And on calculation, the value is found to be 20. Now next question. 25. A block start moving. Earlier questions were direct questions. A block start moving up an inclined plane of inclination 30 degree with the initial velocity v0. It will come back to its initial position with the velocity v0 by 2. Then the value of the coefficient of kinetic friction between the block and the inclined plane is close to 1 by 1000. Then the nearest integer to I is. Now look at, this is our inclined plane, angle is theta. And when it is projected up with the v0, it travels this distance s and reaches here is the initial velocity v0. Here final velocity vi for upward journey, vi is equal to 0 and vf is equal to 0. vi is v0, vf is equal to 0 for upward journey. Whereas in the reverse journey, v initial is 0, v final is equal to v0 by 2. The downward journey. This is upward journey, this is downward journey. Upward journey, you know v square, what is our basic formula? V square equal to u square plus 2as, or s is equal to v square minus u square by 2a. Here yes, for the forward motion as well as the reverse motion are the same. The length of the inclined plane, whether it go up and down, are the same. So S is the same for forward motion. Same during forward and backward motion. Therefore, you can equate for forward motion. Forward motion, when it move up, Final velocity is 0. So phi rho minus initial velocity v0 square by 2 into what is the acceleration when a body move up an inclined plane? G sin theta minus mu g cos theta. When it moves up, plus G sin theta plus mu g cos theta. When it moves up, when it moves down, equal to, this is yes, to A. When it moves down, final velocity v0 by 2. So v0 by 2 whole square minus initial velocity 0 by, but the acceleration down the inclined plane is equal to 2 into G sin theta minus mu g cos theta. When it moves up and move down, the distance displacement is the same. So equate them. What is this? Will cancel out. V square will cancel out. Therefore, what you got? G sin theta plus mu g cos theta is equal to this 4 4g sin theta minus 4 mu g cos theta. G will cancel out. Now you can see that, take to the other side, about 3 sin theta is equal to, take this side, is equal to 5 u cos theta. Therefore, what they required is coefficient of friction, mu. Mu is equal to 3 by 5 sin by cos tan theta. Theta is given. How much is the angle of inclination? Is 30. Therefore, that is equal to 3 into tan theta 1 by root 3 by 5 into 1 by root 3. Root 3 by 5. Mu is equal to root 3 by 5. Root 3 by 5 means 1.7 by 5. Represent that in that format. And you can get that is equal to 0.05. 0.03. 1.5 you write in that format and get the value is equal to 0.35. The value, numerator value is equal to that much. Now, this one calculation is 0.35. Now, you have to represent that in terms of 1000. Therefore, 0.35, we must get this value. And therefore, it must be written like this. 35 by 1000. This can be written as 35 by 1000. $350. So 350 by 1000. 350 by 1000 is equal to 0.35. So our answer is equal to 350. Answer is 350. So that is our answer, and that finishes that paper. Thank you.